Malware sandboxing is not magic malware detection. It is a safe way to observe unknown code without trusting it on a production endpoint. For SecurityX, think like an architect, isolate the sample, record behavior, compare signals, then decide what containment or tuning action is justified. The most important design decision is isolation. A sandbox should not share production credentials, direct routes to sensitive systems, or unmanaged internet paths. If the sample escapes, phones home, or steals a token, the blast radius should still be a lab environment, not your enterprise. A useful sandbox does not just say malicious or benign, it shows behavior. Which process spawned? What files changed? Which registry keys or startup locations were touched? What network destinations were requested? The value is the behavior timeline that a defender can validate. Sandboxing is dynamic analysis, but it should not replace static analysis. Static checks can reveal hashes, strings, packers, imports, and metadata. Dynamic sandboxing reveals what the sample actually tries to do. Strong analysis combines both, then records the confidence level and limitations. A sandbox report is not absolute truth. Malware may check for virtual machines, unusual hardware, missing user activity, short runtimes, analysis tools, or fake network services. If nothing happened, the senior question is not, are we safe? The question is, did the sample have enough reason to show itself? The output matters when it improves operations. Indicators can enrich SIEM events. Behaviors can become detection logic. File and network artifacts can update, allow, and block decisions. SOAR can use sandbox verdicts as one input, but never as the only reason to take a destructive action. The sandbox environment should match the question you need answered. A suspicious Office document needs a profile with the right application behavior. A Linux binary needs a different runtime. A script may need command interpreters, network simulation, and enough time to reveal delayed behavior. Good sandboxing is configured analysis, not a one-size-fits-all button. Sandboxing often feeds automation, and that is where governance matters. If a high-confidence, malicious verdict triggers quarantine, who approve that threshold? What happens when the file is business critical? Is there a rollback path? Senior practitioners design decision gates, not just integrations. Knowledge check. A finance user receives an unknown invoice attachment. The team needs evidence without putting production endpoints or credentials at risk. What is the best first analysis approach? A. Auto-delete every suspicious file. B. Use isolated detonation evidence. C. Share production credentials. D. Trust a clean result blindly. The strongest answer is B. Use isolated detonation evidence. Auto-deleting everything can disrupt business and hides learning. Sharing production credentials breaks isolation. Trusting a clean result blindly ignores evasion. The SecurityX mindset is safe observation, measured competence, and evidence-backed action. The common mistake is treating the sandbox verdict as absolute truth. A malicious result still needs context and scope. A clean result may be caused by evasion, missing dependencies, or an unrealistic profile. Use sandbox results as a strong signal, then corroborate with endpoint telemetry, threat intelligence, and business context. The SecurityX takeaway is simple. Do not think of malware sandboxing as a button that says bad or safe. Think of it as a decision system. Isolate the lab. Observe behavior. Corroborate signals. Governed automation. That is how sandboxing becomes enterprise security architecture instead of a risky toy.